Okay, this is CTrautman. This is the sheep heart dissection practical for Biology Lab 221, fall 2018 semester. And before I cut into the organ here, I just wanted to kind of go through the external features. We are looking at the anterior surface of the heart. This would be the left ventricle with the apex here inferiorly. And then we can kind of see peeking up here the auricle of the left atrium and the auricle of the right atrium here. This is the pulmonary trunk we see here, and the anterior interventricular sulcus. If we turn it over, then this would be the right atrium and the left atrium, the left ventricle, the right ventricle, and this portion here of the atrium is this wide portion is considered the base. When it is properly situated, then the base points towards the left shoulder and is on the posterior side, whereas the apex is the inferior point pointing towards the left ilium. Okay, and then just real briefly want to point out some of the blood vessels here. We've got the pulmonary trunk, which leads from the right ventricle and out towards the lungs. Here we have the aorta, posterior to the trunk, that leads from the left ventricle out. And then if I flipped around here, I believe this is the superior vena cava that leads into the right atrium. All right, so I cut through the heart and I tried to find the just cut into the right atrium. And was having a hard time, so I ended up doing not completely a even frontal cut. So as it is shown here, this is the anterior portion of the heart that I've got here. And because I didn't do an even cut, it's a little bit easier to show on this one here. Right, so blood would come into the right atrium, which is easier to see on this piece here. It comes in through the superior inferior vena cava into the right atrium. And then it's expelled through the tricuspid valve, or the arterioventricular tricuspid valve, into the right ventricle, which is a little bit easier to see. From the right ventricle, then it is forced under pressure when the right ventricle contracts up into the pulmonary trunk, which is here. I cut this open so that we could see, one, the path, and two, the thickness of the walls of the pulmonary trunk. From there, it would go to the heart to circulate, dropping off carbon dioxide, picking up oxygen, and then it would come back to the heart via the pulmonary veins, which I actually found. They're kind of cut, or they're kind of flat, so I'm not sure. So pulmonary veins would bring it into the left atrium, and it would go through the bicuspid or mitral valve, which we can see part of here. That would force it into the left ventricle. From the left ventricle, we can see a little bit better that portion. Left ventricle, it would force it up into the aorta via the aorta semilunar valve. So we've got You can see the left ventricle here because of the thicker walls. Here is our interventricular septum. You can see the walls of the right ventricle are thinner. On this one, you can observe pretty well the chordae tendineae, the little strings, heart strings, attached to the papillary muscles. This one actually maybe has a little bit better view of the trabeculae carni, or trabeculae carni, and then some of the chordae too. As far as circulation goes, I think I covered that. It comes in through the vena cava into the right ventricle, from the right ventricle, or excuse me, the right atrium. It's expelled through the tricuspid valve into the right ventricle. From the right ventricle, it goes to the pulmonary trunk, out to the heart to be oxygenated, comes back through the pulmonary veins into the left ventricle here, is expelled into the, left atrium, expelled into the left ventricle via the bicuspid or mitral valve. From there, it goes into the aorta, and it is pumped out to other parts of the body. I think I hit all of the major portions. We've got the anterior interventricular sulcus here. We've got the coronary sulcus here on the posterior side. You can see the posterior interventricular sulcus there. I think that's it.